Hi there, and welcome to the third part of our tutorial on different LLM evaluation methods. This time we are looking at reference-free evaluations. When we are judging the responses without any example, we're just trying to identify specific qualities and make sure it complies with our expectations. Let's take a look. There are a lot of different methods that we can use here. It's going to be quite fun. So we run this type of evaluations in different scenarios. First is when you do not have an ideal answer or it's very hard to prepare one. And second, when you are in production and you're just trying to evaluate the responses online without, of course, having the expected response for each of them. Let's try to imitate something like this. In this case, we're going to deal with the same financial chatbot example that we did before, but we will only have the question, the answer, and the context. Let's see what we can evaluate in this case. There are a lot of simple things that can actually be quite useful if you know what to look for. For example, let's say that we are expecting that our chatbot will always be polite and say hi and hello to the user. So in this case, we can just check if these words are present in the response. So we can use a descriptor that is called includes words. We apply it to the answer column, and we parse the list of words. In this case, we just wrote a very simple example where we test if any of these words is present. In this case, we use the ls says hi. Similarly, we can test for some other situations, like for example, when the chatbot denies to respond. Usually when this happens, it can use words like sorry, apologies, cannot, afraid, and so on. So maybe this can happen, and in this case, you can detect these denials without any sophisticated methods. There are other examples when regular expressions could be useful. Maybe you expect the responses to always include a certain disclaimer, like this chatbot was generated by a bot, or something like this. Or you know that there are some specific error modes, like as an AI language model, you can just check if this exact phrase appears in the responses, or something like certainly. Let's see how it works. In this case, we're just going to apply this simple check. And in our case, well, the interesting part we can find is that we have actually a refusal, because our chatbot says, I'm afraid I do not have information. And it picked up because one of our words that we had here in the list was pretty much afraid, right? So afraid is the sign of a denial. Right, so another thing that we can look at is some simple text statistics. Again, by itself, it probably doesn't tell you a lot about the response, but if there's like a spike or an answer that is too long or too short, this can be useful. Also, sometimes you have a specific requirement right inside your prompt. So maybe you say you should answer in one sentence. So you can check if the answers that are being generated are actually one sentence. You can also pick up if there is a sudden shift in the length of responses in production. Sometimes this happens if there's like some change in the underlying behavior. So for now, we can just look at something simple like sentence count. In our case, we have one sentence in all responses. Sounds good. I know that I keep using a lot of descriptors which are built in evidently, and you are probably wondering, what if there is something that there is not inside evidently? You can actually implement it as a simple Python function. I can just show it here as a very straightforward example where we're testing if the response is not empty. We implement it as a function that takes the pandas series, in this case we are working with columns, and then it returns a transform series which tells us if the column is empty or not. If it's empty, say empty. If it's not empty, say non-empty. So that's pretty much it. And after we implement this descriptor, we are referring to it as a custom column descriptor because it's being applied to a single column. You can also actually create descriptors that use multiple columns. And we run it on our data set, and here we go. None of the columns are empty. Well, that's what we see. But this is the idea. If you have like a more sophisticated evaluation that is not covered inside the library, you can implement it as a Python function. Now, we can also use semantic similarity. Again, we've already seen it when we were evaluating the responses against reference, but in production, sometimes it can also be useful. So what we can do here is we can look at the semantic similarity between the answer and the context. Remember, in this case, we're imitating RAG application. And what can happen if the answer that is being given by the system is not semantically similar to the context that was retrieved? Chances are the response is either unrelated or hallucinated or something else happens, so we might want to signal if there is this low similarity. Another proxy metric we can look at is semantic similarity between the answer and the question. In this case, it's more about the relevance. So basically, if you're asking the question about a certain topic, the response is likely to have some of these words and be semantically similar. So if this doesn't happen, again, this can be a signal that something is wrong with the quality of the response. Let's take a look. Actually, in this case, we can already notice. So first of all, we have like low semantic similarity between both the response and the context and response in the question in this example. And in this example, we are asking like, can we cancel the transaction? The context says something about it, but the answer is, I'm afraid I cannot answer. Right? So in this case, it's clear there's a misalignment, and it's not exactly hallucination, but it's something that is worth looking into. And then we have again our answer, where the answer was like too short and actually not fully representative of the context. And again, there is a very low semantic similarity. We can pick this up and take a look at what's going on. All the other answers look, well, pretty good. We can also use machine learning based models to score specific properties of the response. Sometimes you can pick up an off-the-shelf model which will be already useful for your scenarios. These are usually things like testing for toxicity or sentiment or emotion or maybe presence of personally identifiable information. So some things that are pretty generic and which can be trained on external data to work across different use cases and maybe yours as well. So here we have a couple of examples. Let's take a look. One is using a very simple sentiment model, which basically classifies the responses between -1, not classifies, it actually returns a score, between -1 and 1, where -1 is negative, 0 is neutral, and 1 is a positive sentiment. It is a word-based model, which basically picks up from the meaning of certain words. If we take a look here, what we got, we actually get, well, one response which has pretty negative sentiment because it's about blocking cards, which I guess is a negative emotion, and the charged also has a negative sentiment. So maybe it's not especially useful in this scenario, but it's something that you could apply if you deal with more like open text analysis. And here's another example I want to show. You can actually download quite a lot of models that are publicly available, for example, on the Hugging Face Hub, and use them to your application. So here I picked up a model, which is a zero-shot classifier. Again, this is not an LLM, we're not calling OpenAI or anything, we're just downloading and running a local model. And in this case, this model can work as the following. You pass the candidate label, which in this case could be like a candidate class, to your text, and then ask the model to classify between these classes that you just provided. In this case, I'm importing this model, so I'm using a descriptor that is called Hugging Face, which lets me select identified models from the Hugging Face Hub. And I also need to pass a couple of parameters. In this case, I need to pass the candidate labels. And the candidate labels I picked is finance and other. So basically the idea is to see if the responses that we have, or the answers or the questions that we have, are related to finance or maybe something else. It could be like a useful proxy. Let's see how it works. Again, it can take a few moments if you're running it for the first time because you need to actually download the model and score your data. Here it just finished, and we can see that what we got, in this case, we are scoring the answers, right, to see if the answers are related to finance. And, well, this answer is about transaction, but this answer about the card section, well, actually not precisely finance, right, and the answer where I say, can it answer? Well, definitely not finance. So again, this is something like a useful proxy, and I'm not telling you that you can just find a model that will work for your use case, but the point that I want to make is that you can actually use smaller, specific models for some types of evaluations, and you can even train these models yourself or fine-tune the models. It's not about using LLMs, it's about implementing a specific scorer once you know what you're looking for. Now let's come to my favorite, LLM as a judge. In this case, we are doing open-ended judging. So we are not passing the two responses like we did before, but we are passing one response and we ask to judge it on some merits. Let's try to write a custom evaluator for diversity. And in this case, I've already looked at the responses and I picked up on something. So remember we had this response where you just said like you'll be charged to 50. I'd say this response is incomplete, not just because it does not use some of the useful information, but because on its own, it's not very helpful, right? You don't say what it's about, what you're being charged for, and so on. So I prefer my chatbot responses to be more complete. So here I'm creating a judge Again, this is like a tiny illustration which classifies my responses between complete and too short. In this case, I basically want to differentiate between the responses which have some substance and responses which are overly short and not very useful or actionable. So I'm creating this judge and I'm running this judge on my data. And here's what we get. So we can notice that some of the answers that we generated are too short. Well, first of all, this answer that inspired the check is too short, and also the answer that was not giving any information is too short. This is a quick illustration of how you can customize a judge. And we are going to have a whole session which will be dedicated to creating and tuning LLM judges, and what's more important, aligning it with our own human labels. Now, I have one more thing I wanted to show, which is a bit of a bonus. In all these examples, we were looking at a single response, like single response or maybe question response and so on. But sometimes you have a longer conversation, so you might have a whole sequence of questions and outputs, like an exchange between your user and the chatbot or something else. And in this case, you can actually apply the evaluations on top of the complete session too. So let's see how it can work. We're going to imitate the dialogue, which follows the same topics which we did, but this time we have an exchange, right? So user asks something, assistant asks something, and so on. So let's create this data set. And now we can run the evaluation. In this case, we created a data set where we basically squished the whole conversation inside a single cell in our data frame, and we are asking LLM to judge this complete conversation. We're going to use a couple of built-in descriptors just to make it quicker. One descriptor is looking at declines. So if at any point there is a denial to respond or to provide something, this might be interesting for us to review. And then we can also look at the PII LLM eval. So this is a check which checks if there are any personally identifiable information like names, addresses, card numbers, and so on inside the conversation. Both could be useful proxy metrics if you're monitoring something in production. In this case, we might want to flag the responses like this for manual review, right? If there was some refusal or there was some personal information, we might want to review what happened. So now I'm running this complete evaluation, and I'm also sending the results to Evidently Cloud because this time the responses are pretty long, so it might be more interesting to look at them in the UI, which allows to browse them. So now if we go back to our project that we already created, we can see a new report that was being added. And we can see that, first of all, we actually had the declines inside our conversation. And second, we even have a PII instance inside our conversation. So now we can look at the data set to explore what happens. I'm going to hide here the actual distributions, and now we can look at the specific scores that we get. So we can, for example, sort by declines, and we can find a conversation where the assistants basically said like, sorry, I cannot provide this information. That's interesting to look at. And then we can similarly sort by PII, and we can notice the conversation where this PII reveal happened, and this is exactly the same that the judge picked up on. Of course, you can also do the similar evaluation in your Python environment, where you would basically just post-process your pandas data frame and search for the specific instances that you want to look at. Now, if you want to look around, I'm linking more examples to how you can try different descriptors, customize LLM judges, create custom Python functions, and so on. But in the following videos, we're going to show a lot more interesting stuff. The next video will going to be all about customizing LLM judges, and after that, it will be all about building and evaluating specific LLM applications. See you there!